we're going to be going through the FRQ section of the review guide. So I'll just kind of take you through this. I'll talk about a few things, and if there's just empty space from just writing, I'll probably speed that up and come back when I'm finished with it. So in question 11, make sure that if you didn't get this today in class, these values did not show up on the printed review guide. If you got it online, you're fine. You got the same one I have. But a lot of them didn't. This didn't print off, so make sure that's written down first of all. Okay, so there's two parts to this question. It says find the probability of getting a height less than 66, right? So I know that the mean here is going to be at 73, and let's just kind of come down here. I'm not really making a big deal of where I'm putting this area. I just know it's below 73, right? This is 66. And I want to find the area less than 66. And so we're going to say normal CDF, and we're going to put in this inputs, right? We're going to go -1 E99 because that's less than all the way down, negative infinity, all the way up to 66. And then we're going to put down 73 as my mean and 2.5 as my standard deviation. I'm going to go ahead and just round these to 4 decimal places. So it's me. This is really small. 66 is quite a distance away. So it's 0.00256, right? So if we wrote that as a percentage, that would be 0.2, let's just say 0.26. And that's a percent, so that's 1/4 of a percentage point, right? So don't be careful when you're writing percentages or proportions. I am very much okay with you just leaving it as a decimal like this, right? I don't have to go to the percent. So for the rest of them, I'm going to kind of just leave it in the decimal format. For the next one, here again, we are centered at 73. This is going to go down to 71 down here. I'm just writing above the line because I don't have a whole lot of space below it. And here's 75 there, right? And so what I really want to know is if I were to kind of section off this, then again, same question as before, but this time, what's the area in between two values? No change in method. It's still normal CDF. Normal CDF. And then we're going to type in the same kind of as before, but this time it's going to be from 71 all the way up to 75. With a mean of 73 and a standard deviation of 2.5. Right, punch that in, and that's going to give me a lot better values here. We're at the center point, so there's going to be quite a bit of area. It's 0.5763, or 57.63%. C's actually got a typo in it. That should have been greater than, but it's not, so we're just going to roll with it. So this one is going to be even smaller than what we saw in part A. So that's going to be really tiny, but we'll just go with it, right? So we're down here. Here we get at 73. Now we're down at 65. So I'm going to repeat exactly what I did before. If I can spell NOR, normal CDF. We're going to type in -1 E99. It's going to be 65 and 73 and 2.5. Now, the one thing I can kind of take from this is that the number that I get from this should be even smaller than what I had previously. If it's not, I know I've got a mistake, right? Turns out you're going to get 0.000, 3 zeros this time, 687. I went a little farther because we needed some more numbers to get in there. But if you left this as 0.0007, perfectly fine. We're going to get down to D now. This one's different. It's not, the question is worded differently, right? It's not the probability of a value below or above. It's saying, what is X if the probability is 0.245, right? It's greater than, right? Here we're saying, if the height greater than X, so here's X, some number separates this into, this is 0.245, right? So the downside of that would have been 0.75. And so I'd like to know the value here. We have the percentile written. Now, if you have, depending on which calculator you're using, I'm going to use the percentile method. So the areas to the left will know what I'm going to type in. So we're going to have inverse norm this time, because now I'm not looking for percentages because I've got both of those. I want to know the value, right? So we're going to do 0.75 And here we're going to go back in and type in the mean of 73 and the standard deviation of 2.5. And this is going to give me a value of 74.73. 74.73. And this would be, in terms of height, 74.73 inches would mark off the top 24.5% or the bottom 75.5 percentile. The difference here is I'm using inverse norm to find a number, not a percentage. And that's number 11. Let's go on to number 12. In this example, this is going to be similar to what we've done in class with some of our book problems about finding standard deviations and different things like that. Okay, in this example, they tell us that we have a normally distributed set of data. It says the mean was 1.29 hours. It says that, however, the company, through post-purchase surveys, has learned that only 25% of the customers succeed in building this under 1 hour. Right? So here is 1 hour, and we know that this area is really only 0.25 or 25% of the area. Would like to know what the standard deviation of this problem is, right? So if you remember, we used inverse norm to get the z-score and then go from the z-score into finding the standard deviation. So we're going to do inverse norm of 0.25. And if I want a z-score, remember we add 0 and 1 for the mean and then standard deviation, and that's going to get us a value that represents the bottom 25%. By the way, this is also Q1. It's the 25th percentile. So if you knew that already, if you kind of worked with this already, you would have known that or recognized that at least. It's going to be negative 0.6745. In this example, going to 4 places at this point kind of helps, but not absolutely critical that I go all the way out 4 places. Right? And I take this, and we're going to be using our z-score formula. So z equals the value minus the mean divided by our standard deviation. So we have negative 0.6745 is equal to, the value we're looking at is 1 minus the mean of 1.29 divided by my standard deviation of whichever I don't know yet. Cross multiply, do your algebra here, and you're going to find out the standard deviation is equal to, we'll just go to 2 places, 0.43 hours. Since these are in hours, I'm going to stay in hours. I'm not going to go to minutes or anything like that. And so that would be the standard deviation here. Part B. In this example, this part of it says that one way the company would want to solve the problem would be to change the advertising claim. What assembly time should the company quote in order to say that 60% of the covers need to finish the desk by then? And so they're asking us to change the X value, right? And so here's my mean. We're still at 1.29. The question is, so 60% is over half of the area. So there's a value here that if I can find this area here, we want to say that 60% of people finish it under whatever time. And I can do this in a number of ways. One of the ways I can do this is to set up my, we're going to use inverse norm actually, and we're going to set it up. We're going to use inverse norm. That's going to be 0.6. We have the percentile, and we're going to use a mean of 1.29. And the part that a lot of people forget is that you found this standard deviation in the previous question, so it's going to be 0.43. Turns out to give you a 1.3989. You could run that just to 1.4. 1.4 hours would be the amount of hours it would take 60% of the people doing this, right? You could convert that to minutes if you really wanted to. I'm not really going to do that here. Let's move on to part C. In this example, or this part of it, we're going to go into talking about, it says, wishing to maintain the less than an hour claim, the company wishes to hope to revise the instructions, labeling the parts more clearly, improve the 1 hour success rate to 60%. If the standard deviation stays the same, okay, we need to get a lower mean value. So here we're looking to find X bar, or the mean of this situation, right? So here, I don't know what that is, right? And so we're going to try to keep it at 1 hour, and let me change that. we really want the 1 to be here because we want to keep that at 60% of the time. People can finish it under an hour. If that's the case, then what does my average need to be? Right? We know they told us their standard deviation is going to stay at 0.43. So the z-score formula is still that thing that I'm continuing to work with. This time I'm going to need to find the mean. So I'm going to need the z-score formula, the z-score value for 60th percentile. We'll start out by doing inverse norm of 0.6. We'll use 0 and 1 here again to get my new z-score. That's going to be 0.2533. And we'll use that in our z-score formula. So 0.2533 is equal to the value 1 minus my mean for the sample. And we're going to divide that by 0.43, which is my standard deviation. Do all the math here, and you're going to find out that your new average needs to be 0.8911 hours. And that is question number 12. On to question 13. Here we have a situation where you have a range of neck sizes, small, medium, large, and extra large. The first question asks, what is the chance that this store does not carry the shirt in your size if you don't fit any of the ones above? So it's asking outside of this range. So the minimum they carry is a size 14. The maximum is size 18. So I really would like to know what these areas are at the top. We know that the center is 15.7. We know that we have a standard deviation equal to 0.7. So I can carry this out in one of two ways. I can use the normal CDF, and I can find each piece and kind of bring them together. And so I think that's the way that we're going to do that. We're going to look at it going above and below. If 15.7 happened to have been exactly in the center and these two values had been exactly the same size, same distance away, then we would be in good shape, but not exactly the center of everything, right? So we're going to go ahead and we're going to use, it did tell us that it's normally distributed, approximately normally distributed, so I'm okay with using normal CDF. So normal CDF here, and we're going to use, we'll find the lower end first, so -1 E99 all the way up to 14, and we'll use a mean of 57 or 15.7 and the standard deviation of 0.7. Okay, that's a pretty large distance away. So I should expect it to be a fairly small number, and it is 0.0076 is the value under here. We do that same thing again on the other side. So normal CDF of this time it's going to be 18 to 1E99 because that's a positive infinity. And so we're going to have the same center at 15.7 and the same standard deviation is 0.7. And we'll see what that is. This is even farther away from the mean, so I'd expect it to be even smaller. You get a little bit of scientific notation here, but I hope we can kind of work through that. 0.00, so it's got a negative e to the -4 at the end of that. Make sure you recognize that. That's a very small number. So moving the decimal behind the 5 into to the left 4 times, right? So we end up getting something that looks like this, right? 0.0005, and I rounded the last one up to 1. Now the actual probability is going to be the sum of these two values. So I've already got them in my calculator. I'm going to hit enter, and I'm going to add these values up just by going back and selecting them in my calculator. So I don't have to type all that mess in. And so we end up getting the total would be the sum of the previous values of 0.0076 plus 0.00051, which ends up giving me a really small number. 0.0081 is the total percent, or total proportion, right? That's 0.81%, so not even quite 1% of the chances to do that. Okay, the next part is in the same light. It's asking me to use this and discuss the normal or the medium size. So we're going to draw a curve like it asks us to. I'm only asked to find the medium size, and so we're going to kind of keep that. Medium is between, this is 15.7. We're going to go from 15 all the way up to 16. So, and I'm estimating this number. So really what we're doing here, and I'm not looking for perfection in this case, but we know that that's what I'm really going to be finding. And so it's normal CDF here again. And we're going to do that from 15 to 16. And we're going to have a mean of 15.7 all the way up to, or not all the way, but the standard deviation was 0.7. Turns out that is about 50.72 percent, or you write the decimal, 0.5072 of the shirts would be qualified as a medium size. Right? Using the normal curve, the illustration here, that's what this is. And where it says calculate it, this is what we did here. These two pieces are required. And that's all we have for question 15, or question 13, excuse me.